Hi, today we're going to be talking about the Morpho butterfly and iridescence. To start, we're going to break this lecture down into 3 different parts. The first part is a review of light and how we see color. The next part would be butterflies, their scales, and the nanostructures found on these scales. And the last part is bioinspiration, a review of color and how we see color. So light is transmitted through waves, and each wave has a different wavelength. The visible light range has wavelengths between 390 nanometers to 750 nanometers. So when light hits an object, the object absorbs a certain wavelength and reflects a certain wavelength back. When that reflected wavelength hits our eye, we perceive this as color. Each color has its own specified wavelength range. Green, for example, has a wavelength range of 495 nanometers to 570 nanometers. So if light were to have a wavelength of, let's say, 500 nanometers, when it would hit an object, if the object reflects this wavelength back and hits our eye, we would perceive this object as green. Part 2, butterflies, their scales, and nanostructures. Have you ever picked up a butterfly and touched its wings and found a powdery substance on your hands? This powdery substance are the butterfly's scales, and these scales absorb and reflect different wavelengths of light, and this is how we perceive the colors of their wings. For example, the monarch butterfly, we perceive the wings as being black and orange. But what about the Morpho butterfly? This butterfly is iridescent, so at different angles we can see different colors. Look at the Morpho butterfly in front of you. Pick it up and tilt it at different angles. Can you see the iridescence in the wings? We'll explain how the iridescence of this butterfly's wings works in just a moment. The iridescence of a Morpho butterfly's wing is caused by nanostructures found on the scales of the butterfly's wings. So, a nanostructure means that these structures are so small that you can't see them through a microscope, but they're bigger than molecules. So the Morpho butterfly's nanostructure looks like this over here. And this nanostructure, when light hits it, will also still reflect light. However, light will reflect at different wavelengths on different levels. So at the top level, it will reflect one type of wavelength, and at another level, it will reflect a completely separate one. So overall, these nanostructures are absorbing and reflecting and scattering light in such a way that when it reaches the receiver's eyes, it looks iridescent. Not all nanostructures have the same shape. For example, in the emerald swallowtail, this butterfly has a cup-like nanostructure on its scales, and this cup has a top section that reflects cyan and a bottom that reflects yellow. So when we perceive the light from the emerald swallowtail, we see an iridescent green color. Butterflies are also not the only insect, or animal for that matter, to show iridescence. Look at the insects and feathers in front of you. You can see that there are other insects that are not butterflies, as well as bird feathers that also have iridescence. Many beetles, for instance, also are iridescent. Take a look at the ones in front of you. These beetles tend to have small nanostructures that are cone-shaped, and light will hit the cone at a certain angle and reflect the light back. However, at a different angle, it will reflect a different wavelength, and we'll see another color. So overall, once more, it comes back down to nanostructures and their shape. Part 3, bioinspiration. Engineers are currently able to fabricate their own nanostructures which can create their own iridescence. Check out the chip in front of you and turn it side to side. Can you see the iridescence in the chip? The iridescence in this chip is caused from tiny structures that are either printed or etched onto the material. And even though we see iridescence here, this current technology is not quite what we see in nature. However, we are getting closer and closer to being able to exactly copy the iridescence that we get in nature. Being able to replicate the structurally produced color actually can help decrease the amounts of toxin-heavy metals and manufacturing methods that we commonly use to create cosmetics and other fabrics. The idea of structurally produced iridescence has also been used in creating high-performance electronic color displays, such as TVs. Overall, the holy grail of this idea would be able to manipulate photons in a similar way that we are able to manipulate electrons. All right, that's it for this video. So you can stay here and continue looking at other iridescence. Ask one of the volunteers around for help if you have any extra questions. If not, go ahead and feel free to move on to one of the other Bioinspiration tables. Thank you.